Hello, MAC 504 students. This is Professor Hazera, and we're going to be, the next time we'll be talking about biotechs. I separate biotechs into two categories. Small biotechs, which have three characteristics, and think of a small biotech as just a lab. So many biotechs are small and have no product to sell. So they're in a position where they're incurring R&D. Keep in mind that in the United States, we expense all R&D. And they have no product to sell. So in the initial years, at least, they have negative earnings because they have zero revenue and substantial amount of research and development. Their entire stock valuation is based on the probability that drugs in development will be approved by the FDA and marketed. Okay, the next characteristic is that small biotechs, like I just said, have negative earnings. This means that the company has little or no revenue. They do get small revenue sometimes from small amounts of revenue from royalties, that sort of thing. But generally speaking, it's zero to none or little to none. And but they have high R&D. So for the initial years, before they actually get a drug approved, they will have, before they actually get a drug approved, they're going to have negative earnings. What you've got to go through a three-stage FDA approval process before you get your drug approved. Okay, and finally, if blockbuster drugs near approval, and what I mean by nearing approval, if the blockbuster drug nears approval, then the stock will, price will increase. It's interesting to see that there's three stages of FDA development: stage 1, stage 2, stage 3. As the drugs get closer to approval, the stock market actually anticipates that they may be approved and starts driving the price up. So you might get some negative, just around approval time, just before it, you might get some negative PE ratios because the price is going up, but the earnings per share are still negative. Okay, so let's go ahead and take a look at the worksheet for small biotech. Okay, this is a typical. This is theoretical, but it's somewhat typical of small biotechs. Like I said, here I have. I'm going to use 14 time periods. I'm not using a terminal value. You could attach a terminal value here to the end, but I'd rather not do that because just to keep it simple. Okay, so I have time periods. I have 14 time periods, and there's 3 phases of FDA approval. We're assuming that the first phase takes 3 time periods. The end of phase 2 takes, it happens at the end of the 6th time period. At the end of approval, stage 3 end approval. I'm putting those together. In reality, they're different events, but I'm just putting them together for simplicity. And after approval, which happens after period 9, they actually start making money, assuming the drug is approved, and that's the assumption in this exam. Excuse me. The second line item is R&D, and I'm just assuming that this drug has R&D of $30,000 across the board here. And what I'm going to do is, this kind of corresponds with the example on big biotechs. Well, that's okay. I'm assuming that this company has R&D. In this case, this company has R&D that is that they invest up through the end of approval. And you could ask yourself, why would they have R&D after approval? It's because, and this is a big deal in the current situation we're in, because you can actually look for alternative uses for a drug after approval. So let's say a drug is approved for arthritis. You can actually look for approval for the drug to see if the drug can treat other ailments. So it might be psoriasis or whatever that you could use a drug. So if a drug is approved for arthritis, let's say this drug were approved for arthritis, you could still, some of these biotechs, a lot of them invest in drugs to see what alternative uses there are. Okay, and then just I'm assuming that the company has administrative expenses amount of $10,000 a year. Okay, so these first three lines, you'll notice they're just numbers. The first three lines are just numbers, and so they're based on assumption. The net income isn't too hard to see. Net income for each one of those years is just the revenues minus the expenses. For the first 9 years, they have zero revenue minus 40,000 expenses. So for each one of these years, they have negative $40,000 in earnings. Now, once you get out to the 10th year, the assumption is that the drug begins to sell after approval, and you have revenue, an increasing amount of revenue each year, less the same amount of expenses. So you see that the income goes up mainly because the revenue is going up. Now, would this be a blockbuster drug? Is this the pattern for a blockbuster drug? I would say this is the pattern for a semi-blockbuster drug, because what happens in real life, a lot of times you may get an initial, let's say 150,000. This could be in millions too, by the way, but 150. And then a lot of times it'll actually spike to like 5 times that amount in the second year as the drug makes its way into the health system. So a lot of times it'll actually spike. In this case, I just have it going up steadily. But this would be something of a blockbuster, semi-blockbuster. But a lot of times be aware that it'll quintuple, it'll go up by 5 or 6 times in the second year. And that causes for a very large spike in PE ratio. Okay, now let's go through the data on, I'm going to minimize myself here a second. Let's go through the data down beneath. I'm assuming that the company has 10,000 shares. That's probably an unrealistic assumption. I'm doing it for simplicity. An unrealistic assumption because a lot of times, once one drug is approved, they start issuing it's easier for them to get capital. Even though that one drug they can reinvest the cash flow from that one drug in R&D or acquisitions, which is very common. The shares would probably, at that point, the shares, they could probably access the capital markets. Okay, but I'm just assuming for simplicity, 10,000 shares. Okay, the earnings per share, as you can see, is just, for all years, is just net income divided by the number of shares. Notice the pattern in earnings per share. It reflects the pattern in net income. For the first 9 years, it's a negative $4. Okay, and that's because you've got negative 40,000 divided by 10,000 shares. In the 10th year, it goes to 11. That would be a big jump for any company, going from negative to $11 all of a sudden would be negative. And it continues going up after that. Okay, and so based on that, and these are just assumed stock prices. You can see these are just individual numbers. Stock price, I'm assuming during the flat phase, during the first 9 years, stock price stays at $1. At $1, and this is kind of what usually happens. The earnings per share in the third phase, let's say, remain at negative $4. That may change a little bit, but it would remain negative. But the market, the stock market, will start anticipating that it'll be approved, and the market starts driving the price up. Went from $1 here to $50. Starts driving the price up before the company starts making positive earnings, which is that year. Okay, so in a sense, accounting plays catch up. You start off with a negative number for earnings per share, and then once the earnings kick in, the number, the PE ratio will actually go from negative to positive because the stock price goes up. it goes from negative to positive because the earnings go from negative to positive. Okay, you can see where I get the PE ratios. PE ratios are right there. Is where the PE ratios are. Okay, and that's true for all these years. You can see that the PE ratios are there. And so in the ninth year, we're assuming that that earnings are still negative, and the PE is still negative, but the stock price starts popping. So in essence, the PE goes to a larger negative. But then when the drug is approved and you actually start making positive income, then the earnings per share become positive, and then you get a large positive stock price, because a lot of times this stock price, sometimes they go through the roof. I've seen instances where you go from a negative P ratio to a P ratio of 1,000 something. The bump can be that large. Okay, so, but this example is good enough for illustrating the concept. So to review, your earnings per share are negative through year 9, which gives you negative PE ratios up through to year 9. In year 10, two things happen. Your price goes up. In this case, I said it goes up 20-fold, which would be, actually, you can see that the logic of the market is once it is approved, the anticipation of approval starts here. The actual approval means they're actually starting to sell. So the stock price goes up because they're actually starting to sell, and because more people have piled into the stock based on this herd mentality, let's say. Okay, and so in this year, stock price pops. That's still positive, excuse me. And however, earnings in a sense catch up to the stock price, which start catching up to the stock price, and so there's a pop in the PE ratio. A lot of times that pop can be on the degree of 1,000 times because your price is very small, and you get something of a bump, and the larger bump comes here. Sometimes I've seen the large bump comes actually here, but the pattern is the same. You go from small negative to larger negative, and then it pops once the sales actually kick in. Okay, now I'm assuming that the revenue goes up as the drug is marketed, gets into the system and is marketed. Okay, and I'm assuming that they maintain the same number of shares, and you'll see that the earnings per share are getting larger. But what happens is the stock, usually the stock price, it goes up, and the rate of increase may start flattening out. Let's say in the 5th year. Usually it takes longer than that because if the company has a patent, the earnings will keep going up. But other companies can also introduce competing drugs, and you may saturate the market. The total revenue is based on projections of the total number of patient population. So the revenue will go up. It also includes insurance reimbursement, all that sort of thing. How much insurers are willing to pay, how much Medicare is willing to pay. That's what determines your revenue. Okay, so the stock price went up here at $500 per year, but on a percentage basis, it actually started slowing down. That means that the price earnings ratio initially takes a pop and then slows down and kind of flattens out, like it begins going down. And that's very truly characteristic because the company is becoming larger, its products are becoming known, they're mature. It may still have a patent, but maybe as time goes on, the number of patients the total patient population, they start saturating it. And also there can be competing drugs that come on the market. Okay, and then so finally, I'm just going to go ahead and look at the pattern. This is the pattern of the PE ratio I just had. And this is generally how it runs. Now, generally what happens is it's flat from years 1 through 9. This is just the PE ratio you saw above. It goes down around the pre-approval stage and then takes a big pop and then sort of flattens out. Now, in real life, I didn't want to have 30 years in this example, but in real life, the upward, it's not a spike per se. It happens gradually where you might have, it goes up and then starts to, it would be more like a cone than a spike. You know, you'd have it would go up and it might go up a little more and then gradually come down. So rather than being a one-time event, this might be more of a curve. The spike may be more of a curve, more than just a spike and then coming down. But this gets the point across. Anyway, so that's the general patterns for small biotechs. The next video we'll do large biotechs, and keep in mind that large biotechs were small biotechs. Okay, and what they did was they had one or two blockbusters. Amgen actually had two blockbuster drugs, and they used the cash flows from those two drugs. Even if, as they became flat, the cash flows, they could use those high cash flows to invest in R&D and to acquire other companies. Anyway, so next video I'll start with the larger biotechs, and I'll tell you the characteristics of those in that video. Okay, hope everybody stays well. Thank you.